Question 2. Proof by induction that 1, 0, minus 1, 5 to the power of n is equal to 1, 0, minus a quarter, 5 to the n minus 1, and then 5 to the n. First step in proving by induction is checking n equals 1. If I check the bottom left first, we've got a quarter of 5 to the 1 minus 1, and that does indeed come to minus 1. And the other three entries are reasonably obvious. Next step is to suppose true for n equals k. And that means 1, 0, minus 1, 5 to the k is equal to 1, 0, but that would mean that 1, 0, minus 1, 5 to the k plus 1 is the result we've already got for the matrix to the power of k, multiplied by a further 1, 0, minus 1, 5. If we check out the top left, it comes to 1. Top right, 1 times 0, 0 times minus 5 comes to 0. If we check out the bottom left, this is the most complicated one. So 1 times minus a quarter times 5 to the k minus 1, and then minus another 5 to the k. Let's move the 0 a little bit further over. And then finally, 0 times the complicated fraction and 5 to the k times another 5 gives 5 to the k plus 1. So all that remains to be done is to simplify the bottom left expression. And we've got minus a quarter and that's multiplied by 1, and then minus 5 to the k. How many lots of 5 to the k have we got? Well, we've got minus 5 over 4 times 5 to the k, and plus a quarter, and that reduces to minus a quarter, 5 to the k plus 1, minus 1. So it means that the result is true for n equals k plus 1. And therefore true for all n belonging to the set of natural numbers by the principle of mathematical induction.